Section 9.1b is about the greatest common factor. Before we talk about what that is, I want to look at two numbers, 48 and 60, and I want to look at their prime factorizations. So 48 is 6 times 8, 6 is 3 times 2, 8 is 4 times 2, and 4 is 2 times 2. So I'm going to write that out as 2 times 2 times 2 times 2 times 3. There, that's the prime factorization of 48. And now I want to do the prime factorization of 60. And that's going to give us a 2 times 2 times 3 times 5. Now, greatest common factor is the largest number that is a factor of both of these numbers. So the biggest number that goes into 48 and 60. One of the ways you can solve for that is you can list the prime factorization and then circle values that are in common. So if we look here, these two factorizations have a 2 in common, they have another 2 in common, and they have a 3 in common. So what you're going to do is you're going to take those values, you're going to take 2 times 2 times 3, and you're going to multiply them. Well, 2 times 2 is 4, times 3 is 12. So we say that the greatest common factor, or the GCF, of 48 and 60 is 12. That means that 12 goes into 48 and 12 goes into 60, and it's the biggest number that goes into both. Here's the way the greatest common factor is described. The GCF, or the greatest common factor of two or more integers, is the product of prime factors, and that's just what we did on the last screen. We took the product of prime factors that are common to the integers. So you want to list all the prime factors and find the ones that are common. Now, the greater definition is the greatest common factor is the biggest number that goes into other numbers. That's how I like to think of GCF. And so in this example, GCF of 48 and 60 was 12. So let's continue to look at some more examples. Find the GCF of these sets, 15 and 16. Now, if you want, you could break these up into 5 times 3 and 4 times 4, which is 2 times 2, and then 2 times 2 again. And then you could list them right on top of each other, 5 times 3, 2 times 2 times 2 times 2. And now you want to circle all the ones that are in common. Well, if you notice, there is nothing in common. When that's the case, we say that the GCF of these two numbers is 1, because 1 is a common factor of any number. Now, the term that we give for those kinds of numbers is back here on the key concept. We call those numbers relatively prime. There's no GCF except for the number 1. All right, this next pair, we'll break 36 up into 6 and 6, 3 and 2. So we'll list the prime factors there, 2 times 2 times 3 times 3, and don't forget there's an x, and a y, because there's variables there. 54 is 6 times 9, 6 is 2 and 3, and 9 is 3 and 3. So we'll list those, 2 times 3, 3, 3, 1x, 2 y's, and a z. Now to find the GCF, we circle all the common factors and take that number one time. So we take 1, 2, we'll take a 3, we'll take another 3, an x, and a y. So those are all the common factors. So what's that going to be? 2 times 3 times 3 times x times y. Well, 3 times 3 is 9, times 2 is 18. So it looks like the GCF is 18xy. In this example, we're asked to find the GCF of the set, and I'm not going to make the factor trees for these. I'm going to see if you can do it in your head. Think of the biggest number that goes into 12 and 18. And the answer is 6. The largest number that goes into both of those is 6. And you could verify it by making the factor trees and listing the prime factors. How about down here? The biggest number that goes into 27 and 15 is 3. And now we have to figure out the largest amount of A's that go into either one. Well, 1A goes in here and 1A goes in here. Now this one doesn't have 2 A's, so the biggest one that we can say that's in common is 1. And then there's also a B in common. So in this case, the GCF of those two terms is 3AB.